Lesson we are going to continue with some of the properties of exponents, but today we're going to focus on the properties that involve quotients. So the first one we're going to go over is the property that says use the quotient of powers property. So this is when you're dividing two powers. So for example, if you look at the first problem here, we have 7 to the 13th power over 7 to the 8th. So if you think about, like, what does this even mean? So 7 to the 13th power means that you're multiplying 7 by itself 10, 11, 12, 13 times. That would be 13 sevens. That's a lot of sevens. And then 7 to the 8th is multiplying 7 by itself 8 times. So if you think about it, if you had 13 sevens being divided by 8 sevens, anything that cancels out we could do, right? So we could cancel out all of these one for one, and that would leave us with these remaining sevens up on the top. And there's 1, 2, 3, 4, 5. So you would end up with 7 to the 5th on the top, and nothing's left on the bottom, so that would just be a 1. Now, there's a much quicker way to get this answer, because what if you had a problem with, very large exponents? You wouldn't want to sit there and write out a whole bunch of whatever your base is. So if you look at this, we have a 13 and an 8. Well, 13 minus 8 equals 5. So that's what's going to happen. So basically the 8, whatever the smaller number is going to cancel that many of the larger number out. And then your remainder is whatever you have left when you subtract. So 13 minus 8 leaves you with 5. That's your answer, 7 to the 5th. Now, in this case, the 7 to the 5th went on the top of the fraction in the numerator, and that's because there were more 7s in the numerator, or more 7s on the top. So if we're doing problem B, this time we have many more on the bottom. So this time when I do my subtraction, I have 6 minus 2. I'll be left with my extras on the bottom. So just so you can kind of see how this one works as well, the longhand way, if I have 6 negative 1s on the bottom, and then I have 2 on the top, I cancel those 2, and I have 4 left, but notice where they are. They're on the bottom. So we would have 1 over negative 1 to the 4th power. Now, 7 to the 5th, if you worked this out on your calculator, you would get a pretty large number. So if I do 7 to the 5th on my calculator, I would get 16,807. So you might need to work that out. 16,000, I'm sorry, what was it again? 807. And depending on, what you're looking to solve or what answer you're looking to find, if it's a multiple choice, short answer, whatnot, you may be able to leave your answer in the simplified exponent form, or you may have to work it out depending on the problem. Now, in this one over here, negative 1 to the 4th power, well, that's really 4 negative 1s being multiplied together. And we know a negative times a negative is a positive. So we know these two would give us a positive, and these two would give us a positive, meaning we would just end up with a positive 1. And of course, 1 over 1 just equals 1. And if you needed to do it on the calculator, you could always check it. So you could do negative 1 raised to the 4th power equals 1. But basically, anytime you have an exponent that's an even number, if you have a negative number being raised to an even exponent, the negatives are going to cancel each other out. If you have an odd exponent, however, like a 3 or a 5 or a 7, there'll be an uneven amount of the negative number. So some will cancel out, but there'll always be an extra one making your answer negative. All right, so let's take a look at C. Now, before we can do any subtraction here, it's better to combine the ones we have on the top, because we can just add those exponents, if you remember from our properties that we did yesterday. So 2 to the 3rd times 2 to the 9th, we're just going to add up how many 2's are being multiplied together, and we would have 2 to the 12th. Now we can do the subtraction that we were just talking about. Since we have 12 2's on the top, 4 2's on the bottom, if we cancel the 4, 12 minus 4 would leave us with 8, and they would have to be in the numerator because there were more on the top than the bottom if we wrote it all out. So 2 to the 8th would be our answer here. And if you work that out on the calculator, 2 to the 8th power, you get 256. Okay, now example D, sometimes you'll see this written in this way. And remember, if something is not a fraction, if you put it over 1, you can easily make it a fraction. So now on the top, remember when you multiply fractions, you multiply across the top. This is just y to the 18th, and on the bottom we have y to the 7th. Now it looks just like the other problems we were doing, where we just have to subtract those exponents. So 18 minus 7 leaves you with 11, and it would have to go on the top because there were more on the top. And whenever you end up with a 1 on the bottom, you can just get rid of it. However, if the 1 is on the top of your fraction, you need to keep it. So just doing some examples, working on this subtraction. So here both bases are the same, which has to be true. So if you ever have different bases, you can't do this subtraction. This only works when the bases are the same. So 15 minus 6 leaves you with 9, and the answer will go on the top because 15 was greater than 6. So the more of them were on the top. And so then I can just leave my answer as 12 to the 9. Now, if you do that on your calculator, it's going to be a very large number. So I'm just going to leave it in the exponent form. Okay, number 2. We have the same base again, 20 of them on the top, 16 on the bottom. 20 minus 16 is 4. And since there were more on the top, my answer is going to go on the top. Now, negative 8 is being raised to an even power. So it's really like negative 8 times negative 8 times negative 8 times negative 8. So 4 times. So the negatives are going to cancel. And if we want to confirm that on our calculator, we have negative 8 to the 4th power, which is 4,096. So this one could be worked out to 4,096. It's a pretty reasonable number. Okay, then number 3, 13 and 13. So I can add my exponents since I'm multiplying those, and that would give me 13 to the 14th power, and then the 13 to the 9th on the bottom. And now we can do the subtraction, leaving us with 13 to the 5th. And that would probably be a pretty big number if you do it on your calculator, so I'm just going to leave it in this exponent form. Okay, number 4. Let's put these two together. So we end up with w to the 21st on the top and w to the 16 on the bottom. And now we can subtract the exponents, leaving us with w to the 5th over 1. So we can just leave that as w to the 5th power. Okay, number 5, 7 minus 3. We're just going to subtract those exponents there. The bigger number was on the top, so that's where the answer goes. And 4 to the 4th power. We would do that on our calculator. 4 to the 4th power is 256. Pretty reasonable answer to work out on our calculator, so we're going to write that there. Okay, next one we have 9 to the 10th over 9 to the 7th. So if we subtract our exponents, we're left with a 3, and it would go on the top because there were 10 on the top and only 7 on the bottom. So 9 to the 3, or the 3rd power. So if we check it out on our calculator, see what kind of answer we get for that. 729, again, pretty reasonable to be able to write that out. All right, number 7, 6 minus 1 is 5. And then 3 to the 5th power is 243. Number 8, this will leave us with negative 5 to the 1st power because 4 minus 3 is just 1, and anything to the 1st power is just itself, so that's just negative 5. All right, and then here we have 2 negative 7s for our base. 5 minus 1 is 4. The bigger number was on the top, so that's where our answer is going to go. And then we might want to do that on our calculator, taking note that it's going to give you a positive answer because you have an even exponent there. And that's going to be 2,401. All right, over here, this is really over a 1. So when I multiply these two fractions, I get 4 to the 5th over 4 to the 2nd. Now I can subtract my exponents since my bases are both 4. 5 minus 2 is 3, and it's going to go on the top because that's where the bigger exponent was. 4 to the 3rd equals 64 on the calculator. All right, same idea for this one, putting it over the 1, multiplying our two fractions, subtracting the exponents since our bases are the same, gives us y to the 6th. And we don't need to put over the 1 since the 1's on the bottom. Number 12, we have z to the 3rd over z to the 2nd. 3 minus 2 is just a 1, so it's like z to the 1st power, but of course we don't need to write that out. We can just leave this as c. Number 13, we have m to the 8th over m to the 4th. We subtract the exponents, and the answer goes on the top because 8 is bigger than 4. And our final answer would just be m to the 4th. Okay, now 14, you're going to subtract the exponents for these two because they're both m's. So 8 minus 6 is m squared. And that 2 is just going to stay where it was. You're not going to do anything with that 2. So we have 2m squared over 1. So, of course, you can just leave that as 2m squared. Okay, and our second property that we're going to do today is the power of a quotient property. So this is when you have a fraction or a quotient inside the parentheses, and then you have an exponent outside. So the only thing that's going to happen here is that exponent is going to be applied to every term, every variable, every number inside the parentheses that's in that quotient. So anything that's being multiplied or divided, each number and variable gets that exponent. So for example, a, the m would get an exponent of 5. The n would also get an exponent of 5. Now, at this point, you might think you can subtract the exponents, but be careful because they're two different bases. So notice the top is an m, the bottom is an n, and they're different variables, so you can't do anything else here. If they were both the same variable, then you could do the subtracting of the exponents like we just did in the last few examples. Example B, this 3 here is going to go to both the numerator and the denominator. Now, in the last one, we just had variables. There wasn't much else we could do, but here, since the numerator is 3 to the 3rd power, you could work that out on your calculator, and it would be 27. And then the p is just going to stay p cubed. Okay, so looking at some examples then. For 15, they're both variables, but they're different variables, so each one is going to get that exponent of 7. So it's just going to be b to the 7th over c to the 7th. On 16, the top number is 3, and you have the w on the bottom. Now, this case, you see that negative. You have to use that negative on either the top or the bottom. So if you have a choice of a number and a variable, you always want to put it on the number. So this is going to become a negative 3 to the 4th power, and then a w to the 4th power. You never want the negative on the letter. Now, the negative 3 to the 4th power works out to be 81, and you could do that on your calculator. Notice it's a positive 81 because we had an even amount of negatives. All right, number 17, both the top and the bottom are going to get this power of 5. So 1 to the 5th and 4 to the 5th. So 1 to the 5th, I can definitely work that out. That's just 1. And 4 to the 5th, I think you're going to get something decently large, but probably still doable. 1,024. So it'd be 1 over 1,024. Okay, number 18, we're going to do 5 to the 7th and 3 to the 7th. At this point, you could try looking at them on your calculator. What's 5 to the 7th? That's a pretty large number. And then 3 to the 7th. That's a pretty large number. So I would just probably leave it in exponent form. But you could write them out if you needed to. Okay, 19, same idea. We have 2 to the 9th and 7 to the 9th. But 7 to the 9th is going to be a very large number, so I'm just going to leave it in exponent form. Okay, number 20, we have a variable. So this one I kind of like because we don't have to worry about whether or not we need to work it out on our calculator because you can't. So it's x to the third over y to the third. Same thing for 21 here. Both the a and the b are going to get an exponent of 13. And number 22, the 1 is going to get the power of 9, and the z is going to get the power of 9. Now the z, there's not much I can do. However, 1 to the 9th power works out to be 1. Okay. So now you can also use these properties in conjunction with the ones we did yesterday with the product properties, and sometimes you can use them together. Now, generally speaking, when I do a multi-step problem with exponents, I try to get rid of parentheses first, doing what we just did, bringing each number and variable that exponent. So here I have an exponent of a 2. So I'm going to bring it to the 2, the x cubed, the 5, and the y squared. So I'll have 2 squared times x to the, and this x already has an exponent of 3, so I'm going to multiply the 3 and the 2, giving me a 6. On the bottom, I have 5 squared, and then the y squared is also going to get the 2, so I'm going to have to do 2 times 2, and that's going to be a 4. Now 2 squared is 4. 5 squared is 25, and then I still have my x to the 6th and my y to the 4th. But there's nothing else I can do. The 4 over 25 does not reduce or simplify. And then I have an x on the top and a y in the bottom, so I can't reduce or simplify those. Okay, now if we look at example B, I have this 2 on the outside here, so that's going to go to each of these things inside those parentheses. So I'm going to have a 3 squared times a k to the 4th, because it already had a square on it, and then I have another square, so 2 times 2 is 4. On the bottom, I'm going to have 4 squared, and then L to the 5th, and I have another 2, so 5 times 2 is 10. Now, since all these things are being multiplied, I'm just going to write them all over the same fraction bar. On this side over here, we have an L squared, and then we had a 3 and a k squared. So now we want to start making sure we simplify any radicals. So you'll notice here, or not radicals, exponents, I'm sorry. So this was 3 squared, which of course is just 9. And I have my k to the 4th, and then I have my L squared. On this part, I have a 16, because 4 squared is 16, but notice I also have a 3 down here. So I want to multiply the 16 times the 3, and that's going to give me a 48. And then I have my k squared and my L to the 10th. And all I did was write them in alphabetical order so that they'd be the same on the top and the bottom. Because now it's a little bit easier to kind of see if we can divide or reduce anything. So like, does 9 over 48 simplify or reduce? So let's think about that. Does 3 go into 48? And no, 3 goes into 9. And 3 goes into 48 16 times. Okay, then look at our k's. Now this is where we can go back to that subtraction piece that we did at the beginning of the lesson. If we have 4 k's on top and 2 on the bottom, 4 minus 2 leaves us with 2, and they're going to be on the top because that's where there were more. And then with the L's, we have 10 L's on the bottom and only 2 on the top, so 10 minus 2 is 8, but they're going to go on the bottom because there were more. Okay, so practicing just a couple more like this. So here we have a 3 on the outside, so that 3 is going to go to everything. So 3 to the 3rd power, and s to the 15th, because we're going to multiply the 5 and the 3. And then on the bottom, we have t to the 9th. The only thing I can simplify here is I can work out the 3 to the 3rd on my calculator. 3 times 3 times 3, which is 27. And then I have s to the 15th over t to the 9th. And then finally, for number 24, everything on the top, if you want, you can put it all on like one fraction bar like this. You don't need to have it separated. Sometimes it's a little easier to look at it when it's just vertically up and down from each other. Now, right away, I have a 3 on the top and the bottom. I can cancel those. You could have canceled them to begin with if you wanted. So now let's look at what we have here, an m squared and an m to the fourth, using that subtraction property that we learned about in the beginning. 4 minus 2 leaves me with 2, and they will be on the bottom because I had 4 m's on the bottom and only 2 on the top. Now when I do my n's, I have 2 on the bottom, and this is technically a 1 up here, right? So 2 minus 1 is 1, and it's going to be on the bottom, and then that means I need a placeholder on the top of that 1. Now, a lot of this is used in scientific notation. So when you're doing problems in scientific notation, you can use some of these properties to help you. So you don't have to take the numbers into these very large or very small numbers, and you can work with them within the scientific notation. So here it says the distance from Earth to the nearest galaxy is about 10 to the 22nd power meters. The distance from Earth to the North Star is about 10 to the 19th meters. How many times further from Earth is the nearest galaxy than the North Star? So we know that the distance to the nearest galaxy, which is the farther distance, if we divide that by the shorter distance, we'll get how many times farther it is. So we're doing 10 to the 22nd divided by 10 to the 19th. So just like we were doing, we would subtract 22 minus 19, which would leave us with the 3, and 10 to the third would go over 1, and then it would just be 10 to the third. Then if you needed to work that out on your calculator, then you would get the answer. And it says the nearest galaxy is about 103 times further. I think, hold on a minute, that's not right. It should say 1,000 times further. Okay. All right, so one more example there. We have the distance from the sun to Saturn. So let's say here's my sun, and here's Saturn all the way over here, and that distance is 10 to the 12th meters. The distance from the sun to Venus, which is a much closer planet, is only 10 to the 11th. How much further is Saturn? So we want to do 10 to the 12th over 10 to the 11th. We would subtract, and you get 10 to the 1, which of course is just 10. So our answer is 10 times further.